Alrighty, so this is my final project. Let's go through this. All right, so function of each block of the microprocessor. Okay, so this is our counter. This allows us to go through each line of code, machine code that we've put in, which is right here. This one is our first ROM, and it has each command that we're going to be using. So like this decides whether we add, subtract, display, load something to register and whatnot. And yeah, this is our second ROM. So this tells this what function we want to use if we want to use the ALU. So our AND, our OR, our XOR, our add, or subtract. And from here, this ROM tells our ALU what function we want to do. So over here, our ALU will add, subtract, and or XOR, and so on and so forth. And then whatever we do there, or anything we do here, like loading or loading something, giving something a value, will be put into here, our register A. Now we've named so awesomely. And from here, our register A, if we want to display something, we go here and ask for two different registers, naming them port A and port B, and then we send them to this TTL, which will then display in ASCII. So from you should also discuss how to convert a single digit number code and the difference. Okay, so how to convert something from this to ASCII. So we actually need to do two things. First, I guess we don't need to do two things. What I mean is we load certain values into two different registers. Let's say we want to display the number 1 in ASCII. So first we need to go to our handy dandy ASCII table, which I can't do here. And find the two number code that will let us that equals 1. In this case, it's 3 and 1. So we would load a register, let's say register 0 with the value 3. And then we would load a different register, let's say register 2, with the number 1. And then we would have our handy dandy ROM here display it here by accessing those two different codes, and it'll add them together and display it. So here's a kind of example. So that was an H. So for that, we needed a 4 and an 8. Here we had register 0, shown by the code 1004, load register 0, the value 4, and then 1108, load 1, load register 1 with the value 8. And then we'd have it displayed by using the code 3001 display number 3 and then register 0 and 1. All righty. The difference between software subtraction and hardware subtraction. So that is primarily over here. So software subtraction is when we use our XOR and then add. And so, to get our number instead of just using our subtraction. So our software does different things before it displays it, while our subtraction goes through it immediately. It'll change the number into its 2's complement immediately, and then add them together, and then display it. With our software, we have to manually do that here. We have to use our XOR to change a number and then the add function to change it into its 2's complement, and then we would add it to the second number, and then it'll pop out, and then we can display it. And then here's kind of demonstration of it. So hello BJ, 3 plus 4 equals 7, 3 times 3 equals 9, 4 minus 3 equals 1, and 4 minus 3 equals 1. So this first one is we did the hardware one, where we just use the subtraction value, while the second one we used our software. And yeah, you can see the rest of that from our turned in stuff. Yeah, fun.